For a more sophisticated analysis of risks, the probability, impact, and ease of detection can be used with a scale of 1 to 5 for each. For example, the probability scale can be 1, won't happen, 2, not likely, 3, may or may not occur, 4, likely, 5, definite. The scale for the impact could be 1, no impact, 2, not significant, 3, may or may not be significant, 4, significant, 5, severe. And the ease of detection scale could be 1, definite detection, 2, easy, 3, may or may not detect, 4, not easy, 5, impossible to detect. To determine the priority of the risk, each of the values provided for probability, impact, and ease of detection are multiplied to provide a risk priority number, or RPN. The higher the RPN, the greater the risk. Let's look at an example using our construction project. Let's discuss the risk of inclement weather and possible damage to our materials. Using our scale of 1 to 5, let's determine the probability. For the sake of this example, let's assume we are building during a rainy season. What probability would you select? 1, won't happen, 2, not likely, 3, may or may not occur, 4, likely, or 5, definite. Selecting a 4 or 5 is reasonable. If we were building in a dry season, this probability would be much lower, selecting a 1 or a 2. For our example, let's select 4, likely, as we are building during the rainy season. Now let's look at impact. What impact would you select? 1, no impact, 2, not significant, 3, may or may not be significant, 4, significant, or 5, severe. Certainly, we would expect some impact, but perhaps not significant or severe. A rating of 3 may be reasonable. We don't really know if the impact will be significant or not. And lastly, let's look at ease of detection. What detection rating would you select? 1, definite detection, 2, easy, 3, may or may not detect, 4, not easy, or 5, impossible to detect. We do have the ability to see weather forecasts in advance of inclement weather. This would give us time to get materials covered or protected. Most of the time, these forecasts are fairly accurate. We could select a 1 or 2 for ease of detection. Since forecasts are not always accurate, selecting a 2 would make sense. Our selections are placed in a table, like the one shown here, with the headings going across as the risk to be evaluated, the probability scale rating, the impact scale rating, the detection scale rating, and the calculated RPN, or risk priority number. The risk of inclement weather causes damage to materials has a probability of 4, an impact of 3, a detection of 2, and an RPN of 24. To get the RPN for inclement weather causes damage to materials, we multiply the probability 4 times the impact of 3 times the detection of 2, which equals 24. The project manager and project team would repeat this rating process until all of the risks we have are analyzed. We would add a new row to the table for each risk. Once completed, we sort the list with the highest RPN at the top. The highest RPN represents the greatest risk. The risks prioritized to the top of the list need to have a response plan. Risks near the bottom of the list may not require any actions. It is not always feasible to take preventative actions for every risk, which is why we use a technique such as this to prioritize risks before building a response plan for them. How many risks do you build response plans for? This is a subjective decision on the part of the project manager, project team, and sponsor. A general guideline is to have response plans for at least the top third of the risks at a minimum. Having response plans for at least half of the list would be a more conservative approach. Again, there's no rule for this. It depends on the project, the number of risks, and the risk tolerance of the sponsoring organization.